Hi everyone, welcome back to our channel. Today we are going to find the parameters of YA, YB, YC of the equivalent pi-net attenuation network shown in the figure to represent an two-port network, and the following measurements were taken. So these are the measurements taken. V2 is equal to 0 is done by making the output port as short circuit and by making input port as short circuit. We need to find out YA, YB and YC. How to find out? Let us try to do it. Now first try to find out the Y parameters. Okay, so we have the basic equations of I1, I2. Okay, I1, I2 is equal to Z11, Z12, Z21 as well as Z22 into V1, V2. So now from here we can write down the expressions of I1 is equal to Z11 V1 plus Z12 V2 is one equation. Second equation, I2 is equal to Z21 V1 plus Z22 V2 is the another set of equation. Now let's try to apply for our problem. So here the applied voltage is V1, the current of I1 is flowing. So I'm assuming this current has some Ix and this current has some Iy. Okay, initially. So under this condition, what is the voltage at this point is V2. So the voltage at this point is V2, therefore the voltage at this point is also V2. The voltage at this point is V1 and it is shifted here. We are going to have V1 here. Now we are going to find the Y parameters initially. Okay, so sorry, this is not the Z. So this is Y11, Y12, Y21 as well as Y22. So now the ultimate equations we are going to get is this is Y11, Y12, Y21 as well as Y22. So I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 V2. So now when you carefully apply here, we are going to apply Kirchhoff's current law at the node V1. What is the entering current here? So entering current is I1 and leaving currents are Ix. So you can see the current in this branch is Ix, the current in another branch is Iy. Already we solved in our channel. You can visualize there. So why I am solving is already these two are also required. That's why I'm doing it in one more method. So how we are going to write down I1. So I1 is equal to how to write down the current Ix. So the voltage at this point is P1. How to write down the current Ix? So we have I is equal to V by R. So 1 by R we can write down it as Vy. So how to write down the current? Ix is V1 into Ya plus how to write down the current? Iy is V1 high potential minus low potential multiplied with Yb is one set of equation. Okay, so when you come to this node, so let's try to understand the current in this branch is some I2. So for our convenience, I am understanding this current as some Ia and the current flowing in this side is Ib. Okay, already we had done a lot of network analysis, nodal analysis on this method. You can view in the channel. So better you solve problem by problem, sequence wise, then you can have more clarity. So try to apply the Kirchhoff's current law at the node V2. Okay, at this node we are going to apply. So what is the entering current is I2 is the entering current. What is the leaving current is, so one branch is IA. What is the next leaving current is IB. So we can write down this as I2 is equal to, how to write down the current IA? So IA I told we have to write down V into Y. What is the voltage at this point? Voltage at this point is V2, and what is the admittance is YC. How to write down the current IB, which is flowing from 2 to 1. So in this direction I have to write down. So we can write down it as V2 minus V1 multiplied with the value of YB. Okay, so now we have to represent in the standard format. You may ask, sir, why are written Z? Sometimes, no, by solving multiple problems, we should be very active. So sometimes the confusion also may occur. So let's try to write down in a standard format. So I1 is equal to V1 YA plus V1 YB minus V2 YB. So take V1 as an common term. So I1 is equal to, V1 is common, we can write down YA plus YB minus V2 into YB. So here also I2 is equal to V2 YC plus V2 YB minus V1 YB. So you're writing in a standard format. So initially I1, V1 and V2. So here the standard format is minus V1 YB, and in this equation take this equation you take V2 as common. When you take V2 as common, this is YB plus YC. So now compare with the standard equation. Therefore, I1 is equal to V1 into Y11 plus Y12 V2. Next, I2 is equal to Y21 V1 plus Y22 V2. So this is the value of Y11. So this is the value of I12. This is the value of Y21. This is the value of Y22. Now let's try to write down in a matrix form, we can understand better. So Y11 is equal to YA plus YB. Y12 is equal to minus YB. Okay, let's try to write down a little bit for, we can substitute the values. Y12 is equal to minus YB. Next one, Y21 is equal to minus YB. Y22 is equal to YB plus YC. So already we know how to write down Y11 also. So how to write down Y11? So from this equation, let us assume that, so from this equation, as per the given question, let's take V2 is equal to 0. When V2 is equal to 0, this term and this term will become 0, and you are going to have Y11 is equal to I1 by V1, and Y21 is equal to I2 by V1, and next V1 is equal to 0. When you make V1 is equal to 0, this term is 0, this term is 0, then you are going to have Y12 is equal to I1 by V2, and Y22 is equal to I2 by V2. Let us try to substitute in this expression. Okay, so already we have this expression. Let's try to substitute, then we will get direct answers. So as per the analysis given, y11 you can write down it as I1 by V1. So this is I1 by V1. So here what how we are going to get is when V2 equal to 0. That's what given in the problem. V2 equal to 0. I1 value is 2.5 divided by I1 is how much? 10 at an angle 0. Next, so this can be written as I2 by V1, that is equal to, so here what is I2 given? I2 is minus 0.50 divided by what is the V1 value? 10 at an angle 0. So next here, this we can write down it as I1 by V2. So here input port is short circuited. What is I1 value? I1 is 2.5 divided by what is the V2 value? 10 at an angle 0. So this y22 you can identify it as I2 by V2. What is the value of I2? So this is 1.5 at an angle 0 divided by V2 is 10 at an angle 0. So successfully we have been find all the values. So now when you solve it, you are going to get Ya plus Yb is equal to 0.25 mos. Okay, and minus Yb is equal to 0.25 mos, and minus Yb is equal to minus 0.05. Yb plus Yc is equal to uh, 0.15 more. So in this case, already let us take the value of Yb as one value. So the value of Yb we are going to take as 0.25. Okay, or you take this Yb value. So when you substitute here, so in this equation as 0.05, so Ya plus Yb is 0.05 is equal to 0.25 more, and here Yb value is 0.25 more, and Yb value is already how much we have been taken, 0.05 plus Yc is equal to 0.15 more. So from here when you solve, you are going to get Ya is equal to 0.25 minus 0.05, and Yc is equal to 0.15 more, and Yb is equal to 0.05. So this is Yc is equal to 0.15 minus 0.05. So when you solve this, use your calculators and try to solve it. Okay. So when you solve it, I'm also doing with calculator. That's why time consuming. 0.25 minus 0.05. So this is directly 0.2 moles. So 0.15 minus 0.05, which is zero point 0.1 more, and this is so the ultimate answers what we require is Ya, Yb and Yc. So successfully we have been find this value. So how to solve this problem is, first we have to apply the, let's try to review the problem. So first apply the KCL set V1 and V2 and express the values of Y11. You see here already for an pi attenuation circuit. So Y11 is the sum of Ya plus Yb, and Y22 is the sum of Yb plus Yc. That's what you have to understand. And the half diagonal elements are negative of this value, minus Yb minus Yb. So we determined Y parameters first initially now. And now let's try to compare with the standard X. This also can be written as I1 by V1, and already in the problem whenever it is output is short circuit, we had got this parameter. When input is short circuit, we have been got this parameter. Substitute this in the formula and automatically you can find out YA, YB and YC. So hope if you are able to understand the video, please give an like and please share with your friends, and if you have any doubts, let me know in the comment section, and please subscribe the channel if you're watching for the first time, which will help us to do more videos for you with a lot of effort and hard work. The viewers obediently from. So your like, share, and subscribe will help us to do more videos. Why? Because you have to invest a lot of time, money, and everything to do this kind of content. Thank you for watching. We'll meet in the next video.